Welcome back to our programming Windows Forms application tutorial. In today's lesson, we're still on lesson 3, by the way, creating a travel allowance calculator. So in today's lesson, we're still continuing on where we stopped. So this is where we stopped in creating the application. This is what we were able to do in the previous lesson. That's in part 6, I believe. This should be part 7 of the travel allowance calculator series. This is what we were able to do. So we're able to read distances from a text file and store them inside this gigantic two-dimensional array, this distances two-dimensional array. Okay, so we said in the first dimension, um, the the data stored in the first, that's not in the first dimension. What I mean is the first dimension kind of specifies which particular city we're focusing on. Okay, so if you specify any index in the first dimension of the two-dimensional array, that cell or that index you provide. So for example, if you provide 0 in the first dimension, it means you are only concerned with all the distances from Abakaliki. Okay, now the second dimension is what actually selects which particular city from Abakaliki you are talking about. Okay, so if we want to access any distance in the distances array, suppose we want to access the distance from Abakaliki to Abeokuta, what we need to do is we need to access distance 0 in the first dimension because we want the distance from Abakaliki. Okay, now distance 0 specifies, now we're talking about all the distances from Abakaliki. Now the second in the second dimension, that's here, what we're going to specify is the state. That's this not just the state but the index of the state, and which is going to be 0 also. I know this is going to be probably a bit confusing. The reason it's going to be 0 is because Abeokuta is the first is the first is the first item. The distance from Abeokuta, by the way, is the first item stored in the first array in the in the first array of the distances two-dimensional array. I don't know if that makes sense. So what I mean by that is if you go into the first dimension and pick the first cell, you're going to be talking about all the distances from Abakaliki. Okay, so they are going to be like 35. I think 35. If you count them, they should be 35. They're going to be 35 cells. Okay, now in the first cell there's going to be a number. That number is going to be the distance from Abakaliki to Abeokuta. So to access the distance from Abakaliki to Abeokuta, what we need to do is we need to access distance 0, 0. 0 in the first dimension, specifying, well, we want all the distances from Abakaliki, and 0 in the second dimension, specifying that first city from Abakaliki, which is Abeokuta. That's when you arrange the cities in alphabetical order. Okay, now of course we're not going to be going ahead and writing if statements. If the city is Abakaliki, and that's if the start city is Abakaliki and the end city is Abeokuta, then you should take distance 0, 0. If the start city is Abakaliki and the end city is Abuja, then you should take distance 0, 1. Obviously that's not going to be a very efficient program. Okay, so what we're going to do is I'm going to show you a way to actually calculate and compute and fetch out the particular distance you're looking for based on the inputs that are given. That's the start city and the end city. Okay, so already we've already created a method that's going to handle that for now. That's this method. So if you look at this method, if you look at the way we've already constructed it, is that this method is a get distance method. Okay, so you expect whenever this method is called, you expect a number, a floating point number to be returned, and that floating point number that's going to be returned is going to be a distance. Okay, a distance in kilometers. Okay, now the parameters you give to this get distance method is a start city, which is going to be a string. Okay, so for example, it could be Abuja, it could be Abakaliki, it could be any city among the cities, among the Nigerian cities. And then there's going to be a second argument, which is the end city. Okay, so that's all. All this method needs is you give it a start city and you give it an end city, and you expect a result. What's going to be returned is going to be the distance between those two cities. Okay, so I hope this makes sense. Now our job now is to create this method. For now, like we said it should return 100 because we just wanted to test it out. So irrespective of which starting city and which end city you choose, for now it's just going to return 100 kilometers. But that's not what we want. We wanted to go into the distances array, which we've already populated by now, by the way. We've used the Nigerian cities distances to populate it. We want to use that that array to go into that array, and based on the start city and the end city, to fetch out the particular distance we want. Okay, now to do that, the first thing we need to do is we need to convert these cities to indices. Okay, there's a reason why we want them to be in index form, that's in number form. Remember, this is in string form. By the time they come in, they're going to be in string form, and even in string form, I believe they're going to be in capital letters, because if you remember our input, that's our form. Let's go back to the form. Okay, we can't see it now, but if you try to run it, you'll see. Let me just show you. I wanted to show you. I want to show you that you can see the inputs are actually in capital letters. So the cities are going to be in capital letters, and because the method we're going to use is going to be case sensitive, and if you look at the state capitals array, it's the cities are actually entered as small letters. So we need to make sure both of them are either all in capital letters or all in small letters. Otherwise, it's not going to work. Okay, so I think it's either we leave this as in small letters, and instead the inputs that we're getting, we should change them to lowercase letters, that's small letters, before we try to convert it to an index. Okay, now the simple way we're going to convert it to an index is usually in an array usually has a method, a find index method. Okay, so for this state capitals array, for example, it has a start method, and that method, when you call sorry it has a find index method. When you call that method, it expects an argument. If you give it an argument, usually I think it's a predicate. If you give it that argument is going to tell it to find a particular thing. Okay, like it should tell you the index of the result of a particular search. Okay, I know this is not going to make it's not making much sense, but let me give you an example. Okay, so for example, the search we're looking for is we're looking for Abuja, for example. We're looking for an item inside the state capitals array that is Abuja. Okay, so if we say if we call that find index method and pass it that Abuja as that's what we're looking for. We want to find a situation where an item in the state capitals is the same as this Abuja string. It should find the index. What it's going to do is that it's going to return 0, 1, 2. It's going to return 2. Okay, because index 2 in the state capitals array actually has an item that is the same, that matches the search we're looking for. Okay, so the search we're saying is that you should find an item that has the same string as Abuja. Okay, so it's going to return the cell of that item. So basically, in short, what we're doing is we're just saying which index is this Abuja stored. Okay, so that's actually what we're going to use to convert those cities to index or to indices. Okay, because when we come to check the distances array, we can only use numbers. Okay, we can't use strings. That's why we have to convert these strings to index form. Okay, so let's go back to our get distance method. So first we'll have to convert this start city and end city to index form. So I'll first create a variable that will hold their index form. I'm going to call this start city index, and the other one is going to be NCT index. And the first, what I'm just going to do is I'm going to find that index. Okay, I'm going to convert this start city from a string. Remember, it's a string for now. I'm going to convert it to an index. That's which cell in this state capitals array can we actually find the start city. Now, the method we're going to use is a bit complex, but I'll try and explain it. So we're going to say state capitals dot find index, and as you can see, the find index method has 3 overloads. I know this is looking very complicated, but believe me when I say that's the easiest uh, overload you can find. If you press the down button, you'll see that this one has a predicate and a start index um, uh, a parameter, and this one actually has 3 parameters including the predicate. So we're going to use this parameter. So what we're going to do is we're just going to pass it a predicate, and then it's going to find a match for that predicate. Now let me try and explain what a predicate is. Okay, now in fact, I think we haven't done delegates, but actually this predicate is actually a delegate. Okay, this predicate you're seeing here is just a delegate. A delegate is like a method. Okay, it's actually a variable that allows you to store a method. Okay, that's a very simple explanation of what a delegate is. So let me just open notepad. So delegate, um, you can think of a delegate as a variable, or let's call it a special variable that allows the storage of a method. Okay, so usually if you remember the way we store arrays, okay, sorry, not arrays, the way we store normal variables, like we can say int x. Okay, and then we can say x equals 5. We've stored an integer inside that x, right? Then later we can say x equals 10. Now we have changed that. Let me just write that down. Okay, this is just an example. So we say int x. Now this x is a variable. We've declared x as a variable, isn't it? This is just a normal variable. Then we can now later say x equals 5, right? Now we have stored the number 5, the integer 5, inside the x variable. Later in our program, notice we can do something like x equals 10. Now what we've done is we have changed the value stored inside that x as 10. Okay, now if you think of methods, now this is for normal variables. If you think of methods the way we have been treating methods, what we do with methods is when we declare a method, remember this is the declaration of a variable. When we declare a method, for example, we say let's create a void method. So we say void, let's assume it's a private method. So void some method. So the name of the method is some method. Okay, and then we define that method. Doesn't matter what we define in here. So let's say we write some lines of code in here. Okay, so we have some lines of code, doesn't matter what we define in here. Okay, So we're just interested in the structure of how we create a method. So when we declare this method, notice that we can only call this method, usually in our program, of the way we've been doing it, we can only call this method, we can only say at some point in our program, we'll just say some method, right? Now because it doesn't take any arguments, we'll just call it like this. We will just say some method, and these lines of code will be executed. Okay, that's all we can do. We cannot change these lines of code along our program. That's later in our program. We cannot change these functions. That's the functionality stored inside the method. Okay, I don't know if this is making sense. Now, compared to a normal variable, you can say int x equals 5. You have stored, just like we've stored some functionality inside this method, you have stored 5 integer inside this x. And then later you decide to change what is inside 5 to 10. Okay, that's for a normal variable. Now for a method is somehow limited because you cannot change. Once you've declared what is inside that method, you cannot change it. Now that is why a delegate is useful. A delegate allows you to actually do that. Okay, so a delegate is like a special variable. Think of, suppose we declare our delegate as k, for example, or d, for example, right? Now we can say, okay, d equals some method. Remember, we have declared some method which has some functionality in it, right? We can say d equals some method here, something like this. I know this is not how we declare or assign, but I'm just giving you an example. So we can do something like this. Now you have stored this particular functionality of some method inside this delegate, this d delegate, right? Later on in your code, you can, maybe we have okay, later on in your code, you can actually say d equals some other method. Okay, some other method. Notice, okay, maybe somewhere in here we have another method with the same now this is quite important, it has to have the same signature with some method. Okay, that means it has to be void, and it has to it must not take any arguments. Okay, by the way, at the time you declare the delegate, you actually specify, okay, you specify the signature, that's the type of method it can hold. Okay, so here this is not actually how you declare it. Maybe later on when we treat delegate, I'll show you how to declare it, but you are supposed to specify, just like int x. When you declare x, you specify that what you're going to be storing inside x has to be of int data type. The same thing with the method, with the delegate. When you declare a delegate, you have to specify what you're going to be, the method you're going to be storing inside that delegate has to be, for example, it has to be void, and it must not take any argument. So it has to have no arguments. Okay, now that's how you declare a delegate, and then you can now assign a method to that delegate. Now whenever you call d, the functionality of some method is going to be executed. But later on in your program, notice the difference with normal methods. For a delegate, later on in your program, you can decide to change the functionality stored inside d. You can say d equals some other method. That's this method, by the way, some other method. Suppose we have some other functionality in here. So some sorry so maybe we have some other lines of code. Okay, so the functionality inside here is different from the functionality inside here. Okay, so you can later change the functionality stored inside d to another method, so that when you call d now, by the time you call d now, this is going to be executed. Okay, so you see that delegate allows you to treat methods in some way as if you can store those methods, and not just storing and executing, you can also pass those methods as arguments actually. Okay, so you can pass those methods just like you can pass variables like this x, you can pass it as an argument to to another method. You can actually pass delegates as arguments to another method. Okay, in fact, that's what we're going to see inside this find index method. Okay, so if we let's go back to our Visual Studio. So if you look at the definition for this find index method, you can see it takes a predicate. Now this predicate is a delegate, okay? Is a delegate, and it takes a string. This string you're seeing is telling you that it takes a string argument. That delegate has to take a string argument, okay? And the name of okay, here it's just calling it match. It doesn't really matter the name you call that delegate, okay? But what it's saying is that what you're going to pass as this predicate, okay? Let me try and explain what this is. What the functionality, remember this is a delegate, which means it's a method. Now the functionality you're going to pass as this predicate is going to be what is going to be executed to try and find the index you're looking for. Okay, I know this is probably not making sense, but think of it this way. Okay, this predicate, um it's a method, okay, and the method is supposed to return a Boolean expression. Okay, I know this probably getting too complicated, but I'll try my best. Okay, so the method, the delegate or the method is supposed to return a Boolean expression. Now notice what happens if that Boolean expression, and by the way, as it's returning a Boolean expression, it's going to use that predicate to test over every single item that is stored inside this state capitals. Okay, these state capitals are every single item. Okay, and how do you know it's using it to test every single item? That every single item is going to come in as this argument, this string argument. Okay, this string argument is going to take every single item. So it's like a repetitive, it's like a loop. Okay, it's going to run over, it's going to take this method and run it over every single item in the state capitals array. Now when it finds an item which, when passed into that predicate method or into that delegate method, the result is a true. Okay, remember it's a Boolean, it returns a Boolean. So if the result of that predicate is a true, then that index, that's the index of that particular item in the state capitals array, is going to be returned. Okay, it's going to be returned. I know this is probably way over your head, but let's just write the code and see if maybe later when we treat delegates, it's going to make a lot more sense. Okay, so what we're going to do is we're going to say state capitals that find index as the predicate. What we're going to use is we're going to, okay, I'm going to just go back to Notepad, and I'm going to introduce you to something called a lambda expression. Okay, lambda expression. Okay, now a lambda expression is just like a method. Actually, it is a method. Okay, but it's like a short form of a method. Okay, you remember the way you create a method. It actually, a lambda expression is just like think of a method that has no name. Okay, it's like you create a method but you do not give it a name. Okay, that's what a lambda. Now usually if you try to create a method and not give it a name, that's going to be an error. But using a lambda expression, it allows you to create an anonymous method. Okay, so you're able to create a method that has no name. The reason is because you just want to, immediately as you're creating that method is going to be used. Okay, so what we're doing here is, because we're supposed to pass a method as an argument, is going to be, that method is going to be the predicate. Okay, now rather than create a method outside here and then pass that method as argument into the delegate in here, it's just going to be long. Rather than do that, we can just create a method. We don't need to give it a name, as we're creating the method, we're passing it into as an argument of this find index method. Okay, I know that doesn't make sense, but let's just try and follow. I know this is not probably not the best tutorial. It's a bit, to be honest, this is a bit complex, it's a bit advanced, but since we need it to pass over this, and I can't really think of an easier way to code this out, so probably we'll just stick to this. Okay, maybe later on we'll try and understand delegates and lambda expressions. Okay, so what I'm going to do now is I'm going to create a lambda expression, and this is how you create a lambda expression. You just create the normal brackets. Remember, a method usually has a name to the left of these brackets, but because it's a lambda expression, you do not give it any name. You just put the brackets. Okay, then inside, because that predicate takes a string as argument, you'll have to define that string argument. Okay, and now it doesn't matter what you call it. For me, I'm just going to call it item, or you can actually call it cities, or actually let's just call it item. So I'm just going to call it item. This item is going to represent every single item in the state capitals array. Okay, and then to continue our lambda expression, outside this bracket we're just going to put an equal sign followed by a greater than symbol. Okay, this is how you create a lambda expression. We're not done yet, by the way. You then open a curly bracket and close a curly bracket. Now the definition of the functionality of your lambda expression is going to reside inside here. Okay, now remember, because this predicate is expecting a return of a boolean expression, you have to return a boolean expression inside your code. Okay, so inside these curly brackets you can actually write several statements, but make sure at the end, just like a method that returns a boolean expression, just like a method that returns a bool, you have to, at the end, that's the last statement of the method, has to be a return statement, and what is going to be returned has to be a boolean expression. Okay, that's a true or false. Okay, now for this for this particular one, what we actually want every single item in the state capitals array to be tested against our start city. Okay, to be tested against our start city. If they match, if the item matches the start city index, then the index of that particular item should be returned. Okay, now all that returning of the index of the item is going to be handled by the find index method. That's not our problem, but our problem here is to actually state the predicate, that to give it the functionality, what is going to be like the search condition. Okay, what condition is to be met before that the index of this particular item is returned. Okay, so it's a very simple condition. The condition we want is, we want whenever item equals, by the way, notice how we write the equal is a double equal sign. The reason is because this is a boolean expression. You're trying to return a boolean expression here. Okay, so when item equals start city, then the index of this item should be returned. Now the way you're going to do that is you're going to say return. Remember, now what we're doing is we're not actually returning a bool. We are actually returning a boolean here, but the find index method is not going to return that boolean. Okay, the find index method is actually going to return an int, which is the index of this condition being satisfied with that which item in the state capitals array satisfies this condition that we're given here. Okay, I know this is probably way below your head, above your understanding, but just take it. This is how we're going to write it. So it's going to be return item equals start city, and we're not going to forget our semicolon. And then outside here, because this is also a statement, we have to give another semicolon, and this is how you're going to write it. So what's going to happen is that this method, everything here is going to return the index of whichever item uh, equates, that comes the same as start city. Also, by the way, remember we said we're going to change start city to lowercase letters, otherwise it's not going to work. So it has to be start city dot to lower. Okay, so we have to add this dot to lower to make sure that start city is in lowercase letters. Okay, all right, now basically just copy everything here that we've written. We're going to do the same thing for the end city. The only difference is that we're going to say this is going to be end city index. End city index is equal to state capitals dot the same da 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 da. Here is going to be end city, and what this is going to do is that it's going to return the index of that end city and stores it inside the end city index. Okay, all right. Just bear with me. I know this is going to be very difficult to wrap your head around. It took me just to give you a heads up, I think it took me probably more than 2 years to actually understand delegates, just delegates. Okay, it took me more than 2 years to understand delegates. I had to do a lot of reading. Okay, so please, if you're not getting your head around what's going on here, by the way, remember it's not just delegates we're doing here. We have delegates in here, we have lambda expressions in here, we have predicates. Okay, so we have a lot of things going on in here. So if you don't understand it, just bear with me, keep reading on. I promise you there would be a day you're going to wake up and you're going to say, I actually understand this. Okay, all right, so let's just go ahead with our coding. So at this point we've found the start city index, and we've found that we've converted start city from string to an integer with the start city index, and we've converted end city from string to an end city index. The next thing we need to do is we need to find the distance. Okay, now it's very simple. Well, not not that simple, by the way, not that simple. Okay, so the first thing we need to do is let's check and see. You see, the reason we're going to do this the next step what we're going to do is, imagine if the start city is Abuja, okay, and the end city is Abakaliki. Let's go back to by the way, let's open up our Nigerian cities distances. Notice what happens. Remember, this is the Abakaliki distances, and Abuja distances should be this third one, I believe. Okay, so this Abuja distances. Notice if the user enters the start city as Abuja and then the end city as Abakaliki. Now, do you realize that if you say you're going to come into this, that's in the first dimension of our array, we're going to take the second, since Abuja is the start city and the start city index is 2. So we're going to come here, which is 2 in the first dimension of our array, of our gigantic array, and we're going to look into these figures and try to figure out which of them is the distance from Abuja to Abakaliki. Do you realize that there is no distance from Abuja to Abakaliki in these numbers? It's not there. The reason is because the distance is actually in here, so it's not duplicated, it's not repeated here. Okay, the distance is actually in the index at the top. So what I'm trying to explain is, if the start city index, okay, is greater than the end city index, remember Abuja is in index 2 while Abakaliki is in index 0. You can see 2 is greater than 0. Now if the start city index is greater than the end city index, if you try to find the distance, checking in by checking the first dimension of your array and looking and taking the start city index as the start city index, you're not going to find that distance. Okay, that's what I'm trying to explain. You're not, just like in Yola, you can see Yola doesn't even have any distances. That's the last one, which is Yola. I believe the last one is Yola. Number 37 is supposed to be number 37, I believe. Is it 37 or 36? Yeah, I think it's 37. It has no distances. Okay, the reason is because the simple reason is because all the distances from Yola have already been covered, so there is no distance from Yola there. We don't want to repeat ourselves. Okay, so what happens, the best thing you do when that occurs, when you find out that the start city index is greater than the end city index, you just swap them. Okay, so you take the end city index and replace it as the start city index, and you take the start city index and set it as the end city index. Okay, so rather than saying, so if the distance from Abuja to Abakaliki is the same as the distance from Abakaliki to Abuja, okay, so you're still doing the same thing. The only thing you're doing is that you're actually working smart. Rather than store duplicate distances in your array, you're actually being smart and you're compressing your database, and then in your code you're just being smart and kind of using tricks to let's say you're working more efficiently in your code. Okay, your code is being more efficient. Okay, so that's what we're going to do in our code. Let's go back to the code. We have to first check and see. So that's why we're going to perform this check that I'm about to do now. We're going to perform a check and see if the start city index is greater than the end city index, then it should swap them. It should take that start city index as the end city index and take the end city index as the start city index before it tries to find the distances from the distance from the distances array. Okay, so we're going to say if start city index is greater than end city index. Okay, so if start city index is greater than end city index, what it needs to do is we need to first say int. Let's create a temporary variable, int temp equals, and then we store start city index. Now to swap, why are we creating this temporary index? Look at what happens if we try to swap them directly. If you take whatever is in start city index and store it inside end city index, and then next you take what is inside end city index and store inside start city index, notice what happens. Because at the beginning you've already taken what is inside start city index and stored it here, by the time you take what is inside end city index and store it here, you actually have the same thing inside start city index and end city index, and what you have in there is the start city index repeated twice. Okay, now that is why it's just based on the way assignation operation works in program. I know this is like it's very simple to understand. Okay, so it's just taking what is inside here, store it in here. So whatever was inside here initially has been overwritten, and there's no way you can recover it. Okay, the moment you take what is here and you store it here, what was here before has already been overwritten, so you cannot get it back. Okay, so that is why rather than take what is here and store it here, we first take what is here, keep it in some temporary store, and then we take what is here and store it here. Okay, and then we then take what is in the end city index and store it here. You can see by storing what is here inside here, we still have inside our temporary variable what was in the start city index earlier. Okay, and then we can take what is in the temporary index and then put it inside the entity index, and then you have actually swapped the contents of the start city index and the end city index. Okay, so that's just what we're doing. So we're going to say in temp equals start city index, and then we're going to say start city. So we can go ahead and override the start city index, since we have already kept a copy of what was in there before. End city index. Okay, and then we can now say end city index. We go to our temporary store and bring back what we stored there. Okay, so by doing this, you have successfully swapped the items, and notice we are only telling it to perform this swap only if start city index is greater than end city index. Okay, now that is one thing. Another thing we need to watch out is, what if somebody says Abuja, the distance from Abuja to Abuja? That's when the start city index and the end city index are equal. What happens then? Notice in our Nigerian cities, in our text file, that's in the Nigerian cities distances text file, we don't have we did not store distances of a city to itself. Okay, so we also have to take care of that. So we also have to say if start city index equals end city index. So when the start city and the end city are the same, then it should actually, this should be taken care of right maybe towards the ending. This is not where we should be worrying ourselves. It should be when, okay, we can actually just say return 0 here. Return 0. Okay, so why we're saying return 0 is because we just want execution to terminate at this point. Okay, we don't even want the get whatever code we write here to be executed. We just want this gets distance to say the distance from Abuja to Abuja is 0. Okay, so at this point, when it encounters return 0, this get distance method just this get distance method just exits and it returns whatever we told it to return. Now, because we're dealing with floats, we should probably use an F. It doesn't really matter, but let's keep an F there to show that the 0 is a floating point number. Okay, all right, so we've taken care of this case. If the start city index is greater than the end city index, then it should swap so that the start city index becomes the end city index and the end city index becomes the start city index. Now the next thing we need to do, and here what we've done is we've said if the start city and end city are the same, then it should just return 0. Okay, then the next thing we need to do is, this is where we actually try and find the distance from our distances array. Okay, now how do we do that? There's a little trick you have to watch out for, but let's just try and code it out and see. So what we're going to say is distance. So we're going to say float the distance. Now this is the distance we're looking for, is equal to distances. So we're going to go into our distances array, and in the first dimension, what we're going to take is the start city index. Okay, the start city, this is definitely correct, because in the first dimension, all we're worried about is, all we care about is, we just want the index of the start city. Okay, because at this point we are sure that the start city index is less than the end city index. Okay, at this point. Okay, so in the first dimension, we just want the start city index to be selected, and in the second dimension, what is going to be selected? Here we have to be very, very careful how we what we put here. Notice that we cannot put end city this index here. I know this is what will be on so many people's mind, but this is actually incorrect. Okay, and I'll show you why. Okay, so this is definitely correct. In the first index, in the first dimension, we want the start city index, but in the second dimension, it is not the end city index we're after, and I'll show you why. Let's go to the table. Let's go to the Nigerian cities distances table, and I'll try to show it. So remember, this is Abakaliki distances, right? Agreed. This is Abeokuta distances, and this is Abuja distances. Let's just stop here, okay? We're just considering these three. Now, notice what happens. Suppose I want to find the distance from Abakaliki to Abuja. Okay. Now, the index of Abakaliki is 0. So we'll say in the first dimension, it should come to the index 0, which is this. You can see that is correct, right? We're going to find that distance here. Now, notice the index of Abuja is actually 0, 1, 2. Index of Abuja is 2. Now, inside these as arrays, we say take index 2, 0, 1, 2. Now, the question is this actually the distance of Abuja from Abakaliki? And the answer is wrong. Okay, that is not 566 is not the distance of Abuja from Abakaliki. Remember, this 656 is distance of this city Abeokuta from Abakaliki. Now 477, which is this one, is actually the distance of Abuja from Abakaliki. You can see, so taking the index of the end city and saying that is where you're going to look for it in the second dimension of your array, of your distances array, is actually wrong. Okay, if you keep testing and see, you'll see that it's actually wrong. It's not correct. Now, how you're going to actually find that index is something something quite well, I won't say very difficult, but you have to have a good mathematical eye. Okay, look at the way the distances are arranged. Okay, and look at the way the indices for these items are arranged. Also notice something. Notice the last index. Okay, so this is the index 35, I believe. Okay, this is index 35 of remember this index 0, so definitely this is index 35. This index 35 of the first dimension. Okay, notice that in index 35 of the first dimension, it actually has only one item in it. Okay, so basically what we're saying here is you can only pass 0 when you're dealing in the second dimension, when you're talking about index 35 in the first dimension. Okay, because the array actually shrinks as the index of the first dimension increases. Okay, the array shrinks. Okay, I don't know if this is making any sense, but really you really have to have a mathematical eye. Anyway, I'll try to give you the mathematical formula and we'll test it out and see if that works. Okay, so what you need to do is you need to say the start city index minus the end city index. The result is actually supposed to give you the index where you that's the index in the second dimension where you're going to find the distance from the end city to the start city. Okay, actually this is not actually the correct formula. There's still something missing here, but I want to show you. I think we need to subtract 1, but for now subtract 1 or add 1, I'm not sure, but let's just try and follow this up and see what happens. The very simple thing, the good thing about programming is you can actually test it out. Okay, you can always test it out if you're not sure. So let's go to our Nigerian cities distances and take a look. Okay, so remember Abuja index is index what? Index 2. Okay, so let's just write it out here. Okay, let's bring up Notepad and do it in there. Let's bring up Notepad. Okay, so here's Notepad. So Abuja is index 2. Abakaliki is index 0. Okay. Okay. By the way, it should be n city index. It should be n city index minus start city index. By the way, I made a mistake there. Anyway, let's continue. So you can see if you want to find the distance. By the way, first we've already taken care of the first dimension. We said definitely in the first dimension we're going to be looking at index 0 because this is the start city, right? So we're going to be looking at this particular array. Okay, in the first dimension we're concerned with these items. Okay, now our problem is which of these distances, which index among these indices. So this index 0, index 1, index 2, index 3, that's in the second dimension. Index 4, which of these indices is the index that pinpoints the distance of Abuja from Abakaliki? And I said in our calculation, it is the index of NCT index minus start city index, right? Now let's test it out and see. The NCT index, what's the NCT index? NCT index is 2. So we're saying it's 2 minus, and the start city index is 0. So it's 2 minus 0. Okay, that's what I'm saying. I know this is wrong. I just want to show you how you're going to find out the correct formula. So 2 minus 0, the result is going to be 0. Sorry, the result is going to be 2. Okay, let's just put it here. So the result is going to be 2. So I'm saying that if we look at the second index, right? If we look at the second index in the second dimension, right, of these items, that is the distance of Abuja from Abakaliki. Let's look at it. 0, 1, 2. Again, we are wrong. Okay, that is not correct. However, if you trace this down, you will see that as we're going down, what we're getting wrong is very, very little. Okay, like we've reduced the error rather than just taking the NCT index. Sorry about that. Rather than just taking the NCT index, we have actually solved some problem here by using this 2 minus 0. The reason I'm saying we've solved some problem is you'll see that our result is actually shrinking as just as the items in each array is shrinking. That's in the first dimension. The array in the first dimension, as they are shrinking, our result is also shrinking, unlike if we just take the NCT index and just plug it in there. Okay, I don't know if that makes sense to you, but it does to me anyway. Now this is wrong. The reason is wrong is because of actually we didn't take account of the counting of the indices actually start from index 0. Now that is why this is wrong. So because if we take account of that the counting of the index starting from index 0, that's indices of the cells start from 0, we need to subtract 1. So it has to be NCT index minus start city index minus 1. So for Abuja, the distance of Abuja from Abakaliki, after looking at this, in the second dimension, what we want is 2, which is the NCT index minus the start city index, which is 0, minus 1. Okay, this minus 1 is to offset that first index, because counting starts from index 0. Okay, that's why we add a -1. And if we do this, you'll see that we get the correct result for the distance of Abuja from Abakaliki. Now if we go into our first, in the first dimension, we're concerned with only this. That's the first cell. Now if you look at 0, 1, you can see this is correct. This is the distance of Abuja from Abakaliki. Okay, now I know this is like, I just brought it up. I did take my time to actually calculate this out and get the result, but for now, I think the best you can do is you can just take sample tests and see if it actually works. Okay, so another thing we can do is we can say the index of which city is this? This, okay, this is Abuja. The index, the distance of let's just look at our distances. Let's go to our which is the fourth one after Abuja. We have Ado Ekiti. Okay, so the fourth one is Ado Ekiti. So we go back there. So this is Abuja, right? These are the Abuja distances. Now this is Ado Ekiti distances. If you want to find the distance of Ado Ekiti from Abuja, how do we calculate it? Now notice what is the index of Abuja from what is the index of Abuja, which is the start city index. Index of Abuja is 2, so we're going to say the start city index is 2, so we're going to be looking at 0, 1, 2. We're going to be looking at these distances. In the first dimension, we're going to select 2, which is these distances. Now in the second dimension, we're going to be looking at the index of Ado Ekiti is 3, so it's going to be 3, which is the end city index, minus 2, which is the start city index, minus 1. Okay, this is going to be 3 minus 2 minus 1 is going to be 0, equals 0. Now that is going to be the index we're going to be looking at in the second dimension. So it means in these items we're going to be looking at the first, which is index 0. That's this one, which is correct. 400 is actually the distance of Ado Ekiti from Abuja. I hope this is making sense. Now that is how we end up coming up with this. I know it's probably not the best way. It's probably not we didn't actually deduce it. The reason I'm giving it to you is I've already done it before. Like I told you, I've already done the web-based version, so I had already deduced this formula. So it's going to look as if it's just straightforward. It's just like I'm popping it off the top of my head, but I actually had to sit down and deduce that formula. Okay, so you can see that the formula actually works. If you take the end city index minus the start city index minus 1, it's always going to give you the correct index in the second dimension where to look for your distance. Okay, so let's go back to our code, and so basically what we've done is we're going to say the distance is going to be distance is start city index, and then in the second dimension, that's in the first dimension is just the start city index. In the second dimension is going to be end city index minus the start city index minus 1. That is going to be the index that's going to pinpoint on the distance that is going to be returned. Okay, so that is going to be the distance, and here we're just going to say return the distance, right? Return the distance. Okay, we can actually do it this way, or to make our code shorter, we can just, there's no need to store it first, we can just say return this. So we can just say return distances start city index n-city index minus this. Okay, so this is how at this point this get distance method is going to always return the correct distance in kilometers of the start city from the end city. Okay, okay. I know this lesson has gone a bit too long, but since we've come to the end, let's just try and wrap it up and finish off this program so that we can run it and see. We can test run it and see. Okay, so we'll finish the get distance method. So when the compute button is clicked, this is going to happen. The distance is going to be calculated here. Notice the distance is being stored in distance, and then the payable allowance is going to be calculated by multiplying the distance multiplied by allowance per kilometer, and then finally it's going to output the result. It's going to say the payable allowance, and it's going to tell you the distance between those two cities. Okay, so here we're going to keep our fingers crossed and run this program and see what happens. So the first thing I would like to do is, let's first open up this our distances and look at the distances pyramid. Now if we look at the distance of Abakaliki from Abeokuta is 656 kilometers, right? So we expect to see the distance of Abakaliki from Abeokuta to be 656. And to even trick it more, we're going to set the start city as Abeokuta and then the end city as Abakaliki. Okay, the reason we're doing that is we're changing it to see if that swapping of our cities actually works. Okay, so let's go back to our program. We're going to choose the start city is going to be Abeokuta and the end city is going to be Abakaliki, and then we're going to say payment per kilometer. We're going to use 20 naira, and then we're going to say calculate allowance. You can see that the distance of the journey is computing it out correctly, which is 656 kilometers, and then the payable allowance is 13,120 naira. Okay, this is just the first test, by the way. Let's test let's try another one out. So 954 is the distance in kilometers of Yola from Abakaliki. Again, we're going to do the same thing. We're going to set Yola as the start city. So we expect to see 954 and the endpoint to be Abakaliki. We're going to say calculate allowance. Okay, so this is coming out wrong. We're getting 346. We're getting this. Now I'm not sure why we're getting 346. Okay, there is an error somewhere. I'm suspecting we probably have too many items here. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay, there are actually 36. I'm not sure why it's giving us 346. That's that is very frustrating. But okay, so there is a bug somewhere. We might have to debug this program. So this is a normal thing when you create a program. It is very normal to create a program thinking you've done everything correctly, and then when you run the program you find out that at some point the program seems to be working fine, but when you enter some inputs you get wrong results, and the reason is because something in your code is wrong. Okay, and I do suspect I already okay, there are 1 to 36 states here, which makes sense. There should be 36 states. So maybe we should probably end this tutorial here. I know it's probably not a good place to end the tutorial, and we're going to try and debug the program in the next tutorial. The reason is because the tutorial has gone too long, And also I have to take my time to go through the code and try and find out the bug, the reason why we're getting a wrong result. Okay, so we're getting 346 here. It's giving us this rather than 954, which is seems to be the correct the correct distance. Okay, by the way, let's test from Abakaliki to Yola and see what happens. So if we say from Abakaliki to Yola, what do we get? To Yola, calculate distance. We're still getting 346. So yeah, we do have a bug in there. I'm just going to do one more test from Abakaliki to let's see, to Abuja. So should be 500. Abakaliki to Abuja should be 477. So we're going to do that. Abakaliki to Abuja. Where's Abuja? Abuja. By the way, I think we did we create this I'm trying to see if we actually created that. Okay, we didn't. We said we were going to uh, shorten this, make it easier for the user to enter the states, so that once he begins to type the state, so for example, if he types A, B, then this list of states should be limited to only states that contain the letters A and B. Anyway, that's going to be for another lesson. I'm going to terminate this lesson here. As you can see, we still have a bug in our program, so we're going to try and debug it in the next lesson. I'm going to take my time and look up the program and see where we're making mistakes in our code. Okay, so I'll see you in the next lesson.